This video tutorial from exocad will show you some of the new features from exocad's latest release, Plovdiv version 2.4. The Plovdiv release includes more than 64 new features, as well as 45 enhancements to existing functionalities, with the main focus on advanced removable design. In the Denture module, the software provides new manufacturing methods for all denture situations. Milled or printed production methods may be used for denture bases and denture teeth. For production of the monoblock try-ins, you can now easily export and save a monolithic try-in denture during the design workflow in the wizard. Note: monoblock can only be created for open and semi-closed libraries. Bridge connectors between denture teeth are enabled to facilitate post-processing and assembly of milled or printed denture teeth to the denture base. Also, bridge connectors can now be placed below the gingiva or behind proximal contacts. For additional information on full dentures, please refer to our full denture video tutorial. It is now possible to design single arch dentures in a new simplified workflow with a dedicated model analysis wizard. Bite rim scan is not needed for single arch denture, and the model analysis will be done on the antagonist. Users with the Virtual Articulator module may use Virtual Articulator while designing single arch dentures. We also have the choices of different production methods with relevant options and parameters for a single arch denture. For additional information, please refer to our single arch denture video tutorial. In Plovdiv at beta phase, the PartialCAD is now integrated with DentalCAD. With this new integration, DentalCAD allows you to place the teeth being restored by the framework and continue the design of the partial framework with the PartialCAD in the last wizard step. And once you've finished the design of the partial framework, you can continue the design of the partial denture's gingiva or an overdenture in DentalCAD. Select Partial Framework for teeth to be restored by a partial denture. Some parameters and wizard steps are different based on the chosen material. Note: in this demo sample, the teeth placement as pontics and the partial framework design have already been finished, and all corresponding files are available in the sample folder. The aim of this sample is to design the overdenture. To design the overdenture, start the DentalCAD by loading the existing scene file. The software will now open at the last wizard step of the tooth placement. As already explained, here you can start the design of the partial framework by selecting PartialCAD Design. In our case, the partial framework has already been designed, and an additional new option appears in the wizard to allow you to design the overdenture. Select Design Overdenture Gingiva and proceed to Next. If there is partial framework design available in this project, you'll be prompted to load the design and merge directly into the scene. Designing the overdenture starts with the virtual waxup bottom step on the wizard, and you'll be asked to set the insertion direction. Click to set insertion direction from the view. You can also set the view parallel to the insertion direction. Under the gingiva's bottom properties, different options are available for gingiva adaptation purposes. Offset creates a gap between the jaw scan and the gingiva bottom. Smoothing fills out edgy cavities. Milling diameter adds a tool radius compensation for the tool used to mill the gingiva area. If the checkbox Include Partial Framework is activated, the partial framework will be included in blocking out, and the overdenture will be designed on top of the model including the framework. If it is not activated, only the jaw scan will be blocked out, and the gingiva part of the overdenture will be designed directly on the jaw scan without including the partial framework. Click on Apply to calculate the blocking out. Use freeforming if you desire to manually block out certain areas. Here you can add and remove material as you are used to doing in free-forming. Note that removing material is only possible on blocked out undercuts. The depth of the undercuts will be visualized with a color scale. When you are done, proceed to the next step. The wizard will prompt you to draw the gingiva margin line. It is exactly the same margin draw mode as for the margin line of crowns and copings. Add as many points as required to design the border of your gingiva area. Finish drawing the margin line and apply with a double click. You can still do corrections on the margin line, add points with the left mouse button, and remove points with left and right mouse buttons simultaneously, and apply again to recompute the changes. Repeat the gingiva margin line for the other side. The gingiva design shape can be influenced using several parameters. You can change the thickness of the base, the cervical border thickness around the teeth, and smoothing of the surface. You must confirm each adjustment of parameters or margin with Apply. When you are done, proceed to the next step. The gingiva freeforming tool differs slightly from the standard exocad freeforming tool for crowns and bridges. The anatomical freeforming mode provides two different options. The default small region option allows you to move smaller parts of the gingiva, whereas huge region allows you to move major areas. When moving bigger areas, bottom and boundaries are fixed by default. If you uncheck this option, the boundaries and bottom will also be moved. The desired thickness of the gingiva will be maintained only when morphing parts of the gingiva. Note, changing the thickness value will not recompute the entire gingiva thickness. Furthermore, the thickness can be visualized with an adjustable color scale. Freeform Gingiva tab gives you access to the virtual wax knife. This tool behaves exactly the same as in the standard freeforming mode, where you can add, remove, or smooth material with different brush types adjustable in size and strength. This tool can be used for the final touches. Now proceed to the next step. In this step, you can change the parameters for the adaptation of the tooth pocket in the gingiva. Note, adaptation will trim teeth on the bottom to always fit inside the base. Apply the changes. By clicking on Next, the software will merge and save the gingiva parts and export the STL files. Jaw motion with Zebris device can now be used as a digital facebow and import articulator parameters automatically. Load jaw motion Zebris sample with scan marker for jaw movements. Note, this dataset requires the jaw motion module to be activated. Click on Design to start the CAD application. The first step in the wizard is Scan Alignment. Check the result of the alignment. You should see an evenly green surface on the important areas of the aligned parts. Click on the Next button to proceed. The software will ask you to select the jaw movement type. In this sample, we choose Zebris. In this step, the matching is done on the jaw motion device. You can rotate both objects to have similar orientation, or click a common point on both objects. To correct, click another point to restart matching, or change rotation and then click Restart Matching. Once the matching is done, we will continue to Start Virtual Articulator. If there is no contact between the upper and lower jaw, the software will ask you to decide whether you wish to leave the gap or remove it, which will pull the upper and lower jaw together. Select the new option Load Digital Facebow Data Articulator Settings. The Zebris compatible file import now accepts jaw motion files additionally to XML files. Note that the parameters such as Bennett angle are not imported from a scanned articulator position, but directly measured and transferred with the facebow. We have prepared this case explicitly for this training video, and the demo sample delivered with Plovdiv does not contain such a facebow file. Pre-op or wax-up scans can now be included or excluded via checkboxes for the Virtual Articulator movement simulation. This allows workflows where the articulator should be guided by the original patient's scan data. Note, a new articulator, FAG Quickmaster, is now available. Click Choose which teeth influence articulator movement to open a new tab where you can define teeth which should be considered or ignored during articulator movements. If a pre-op scan or a wax-up scan is available, then an additional By Scan tab is available. Select either pre-op or wax-up scan to perform the movement simulation with the selected object and click on Apply. Note that the movement will be executed by using the pre-op or wax-up. If the margin lines have been imported and were applied without any modification, the software will ask you whether to apply the margin line for each tooth automatically or to review each margin individually. Change any desired parameter for the crown bottoms and proceed to Next. Note, if you wish to change parameters for individual teeth, switch to Expert mode. In Plovdiv, 3 new natural tooth libraries for restoration design are available. Exofan, crafted by Marco Annucci, also available for thimble crown design, and Passaris and Passaris Elderly, crafted by Ilias Passaris. In Plovdiv Dental DB, we have added a new cervical adaptation option for anatomical crowns, for reduced crowns, as well as for the implant-based crowns. With this option, you can influence the behaviour of cervical adaptation of the library teeth. Pull to Margin adapts the library tooth to the preparation margin or emergence profile. Let's see this in action. After the tooth placement and abutment bottom design, you can see the margin of the anatomical tooth library is pulled to the implant platform or the margin line. The tooth may become deformed in the process. Preserve library shape will load pontics instead of crowns in tooth placement, which in fact is similar to the digital wax-up workflow. You can see that closed pontics are loaded. You notice that after the tooth placement, the software will create the minimum thickness around the die or implant and keep the exact shape of the tooth library. Let's compare these options for a screw-retained bridge. Please note, the digital waxup feature is still available and can still be selected as an option in the anatomic or reduced waxup reconstruction type. Starting with exocad Plovdiv, designing substructure on implants using thimble crown tooth libraries and superstructure on these thimbles can be done in one workflow without the need for rescanning or changing projects. We will show this with the new demo sample called Screw Retained Thimble Substructure Sample. Note, in this sample case, we have chosen screw retained implant base. And by selecting Yes on Design with Thimble Crown Workflow, you can perform the thimble primary part and secondary part design in one session, and thimbles are automatically loaded in the shrinking step. The selected work type determines which superstructure will be designed, and can be reduced with the usual shrinking features after the thimbles are loaded. This option is only available for anatomic crown, anatomic pontic, coping, and reduced pontic. And the libraries that contain the thimbles must be used, such as generic and exofan. You have the possibility to connect the secondary crowns as a bridge. In this video, the tooth placement is already done, and we will skip the freeforming and adaptation to continue with the virtual wax-up bottom. For more information on different options for bottom properties and block-out undercuts, please refer to our thimble crown video tutorial. Click to set insertion direction from the view. Click on Apply to calculate the blocking out. Use freeforming if you want to manually block out certain areas. Proceed to the gingiva design step to draw the margin of the gingiva. The software will ask you whether you wish to design a single gingiva for all neighbouring teeth or design separate gingiva parts for each planned bridge or crown. Add as many points as required to define the gingiva area. Finish the drawing with a double click. Choosing different parameters will result in a different gingiva design shape. You can change the thickness of the base, the cervical border thickness around the teeth, and the smoothing of the surface. You must confirm each adjustment of parameters or margin with Apply. Then proceed to the next step. If required, you can use gingiva freeforming tools to make some adjustments to the gingiva design. The default small region option allows you to move smaller parts of the gingiva, whereas huge region allows you to move major areas. When moving bigger areas, bottom and boundaries are fixed by default. If you uncheck this option, the boundaries and bottom will also be moved. Furthermore, click on the Free tab to access the virtual wax knife. Then proceed to the next step. Note: if thimble has been selected in DentalDB, the thimble library is automatically loaded. Click Apply and proceed to the next step. Here it is possible to freeform the thimble crowns. You have exactly the same freeform features as in the tooth placement. By selecting the Entire Tooth option in Anatomical Freeforming and holding Ctrl, you can rotate the thimble crown. And by holding Shift and Ctrl, you can scale the thimble crown. When you are done, proceed to the next step. In the next step, you can choose to design thimble superstructure or to continue without the thimble superstructure. Now we can continue in the wizard with defining the thimble crown margin. Note, the margins are already predefined and calculated automatically from the cervical border of the thimbles, but you have the option to modify each tooth in Correct and Draw tab. If the predefined margin lines have been applied without any modification, the software will apply the margin line for each tooth automatically. Also, you have the possibility to change the margin lines in Expert mode. In the thimble crown bottom step, the cement gap and additional spacing options can be set in the first tab of the cement gap dialog. The second tab of the crown's bottom dialog gives you access to parameters that define the shape of the crown border. And the third tab gives you access to undercut related options and milling parameters. Note, to change parameters for teeth individually, switch to Expert mode. Proceed to the next step. The software will generate the crown. Proceed to the next step. After the gingiva is generated, in some cases the gingiva might slightly overlap the thimble margin. In Plovdiv, this will be adjusted automatically by using the Adapt to Thimble Crowns in the Freeform Gingiva step. Let's look at the cut view to see the virtual gingiva, which has been cut using pre-configured parameters around the thimble crowns. These parameters are used to create space for the border and ceramic of the secondary crown. Proceed to the shrinking step of the secondary parts. Note, if you wish to produce crowns without any shrinkage, you can set the depth to 0. Select from the Cutback Design library. There are two different cutback libraries, facial ridges and incisal ridges. The facial ridges will reduce the tooth with ridges on the facial side where the incisal edge remains untouched, and the incisal ridges affect the facial and incisal side. Click Apply. Proceed to the next step. The second freeforming step allows you to freeform the secondary parts or to adapt the restoration to the antagonist, the gingiva, and the adjacent teeth. Proceed to the last step. Please note, manufacturing such a structure in a single operation entails considerable complexity, and therefore thorough testing is recommended. Immediate load is now available in Plovdiv as a full release. You can import implant planning files from Exoplan into DentalCAD and design your restoration directly on the planned implants. Also, immediate load is now possible in Model Creator standalone software, for example, to design models with lab analogues for planned implants. Note, this workflow requires the implant module as well as the Model Creator module. In this demo sample, we have selected an implant-based anatomic crown on custom or stock abutment. This demo sample is available with DICOM data in the project folder. Select Design. The software will inform you that the implant planning information was found for this project, and you can load planned implant positions or teeth setup made during the implant planning. We start by importing the implant planning info file and the tooth placement. If you have copied and installed the Exoplan implant libraries to the DentalCAD implant libraries, the planned implant will be displayed as you can see here. If you did not install those libraries, only a placeholder will be displayed instead. In this step, we can select the desired connection for the implant and the reconstruction types. You can select stock abutment from the library. It is very important that you have correct prosthetic libraries that are compatible to the exoplan libraries. Note, your reseller will provide the software to you pre-configured with a working implant library setup. You can also do a custom abutment on a tie base. In this case, depending on the library, you will have three parts: the tie base, the customized abutment, and the crown. In custom abutment, direct to implant, you will have three options. First option, if you have a library with an interface that can be milled. Second option, if you have a pre-milled part as a tie interface. And the third option, if you have a pre-milled part as a collider. You can also do a screw-retained crown on a tie base. As well as screw-retained crown direct to implant with the same options as customized abutment. For more information, please refer to our exocad quick guide called Using the Immediate Load feature in combination with exoplan. You can also access our library download portal on the exocad website. In Plovdiv, you can change implant connection without losing the abutment bottom design in the expert mode. Select Switch Implant Connection Library. The software will only show you the compatible implant library from the various manufacturers. You can rotate the implant connection depending on the possibilities available for each implant, and select options such as different chimney heights or the screw access angulations. In Plovdiv, we have different options available to design an offset substructure. One way is to create an offset coping substructure on a scan bar by selecting Offset Coping as our work type and On Substructure Scan as our implant type. This would create an offset structure directly over the bar, following the same margin as where the bar intersects the ridge. The first step in the wizard is a 3D data editor. Here you have the option of cropping the scan data or closing the holes, but we can skip this step as the new blockout algorithm will close the holes automatically. In the next step, the software will detect the insertion direction, close the holes, and block out the undercuts. Note, if you wanted to adjust the insertion direction, use the Insert from View button before defining the margin. Set at least 4 points to define the bottom margin and edit the margin line if required in the Correct and Draw tab. Proceed to the next step. In Design Wax Up Bottom step, the cement gap is set as default for a coping, but you can change that according to your manufacturing process to control the fit and the friction required between the bar and the offset substructure. In the next step, you can change the shape by region or by using the Add and Remove Material tools in the Freeforming tab. You also have the option to add attachments in the Attachment tab. We have new attachments available, such as Donut Shape Retention. Place the attachment by mouse right-click. You can move it freely by holding the mouse button and dragging. Hold Shift to move along the insertion direction. Hold Ctrl to rotate around the insertion direction, and hold Ctrl and Shift to rotate freely. Apply the changes. Note, the attachments can also be moved in Anatomic Forming tab by selecting the small region and click and move. Another addition to the attachment library is the ring shape retention. You have the possibility to scale the attachment and, if desired, to cut on the gingiva side to create the required gap for the acrylic below the attachment. To add, remove or smooth material, use the exocad known Freeforming tab. In the last step, you can merge and save the indications. The other way is to create an offset substructure on a scan bar. By selecting Offset Substructure as our work type with a pre-op model scan. This type of substructure includes a gingiva part. In the first wizard step, you have the possibility to correct the pre-op scan position. Follow the steps which have been explained previously. Note, in the design bottom step, the parameters are set for the offset substructure. After designing the substructure bottom, the next step is designing the gingiva bottom. Click to set insertion direction from the view. Under Bottom Properties, you can change the offset value, which is the distance from the surface scan to the underside of the structure as it gets to the ridge. This creates a gap for the acrylic. Smoothing value defines how closely the wax-up bottom matches the shape of the ridge. Click on Apply to calculate the blocking out. You have the possibility to freeform the blockout area. The next step is to draw the margin, as has been explained earlier in this video. Note, with this second margin line, you mark the blocked out area for the acrylic material, and it can include extensions over the ridge for the additional retentions for the acrylic. Once you've finished placing the last point, the software will calculate the surface. In the next step, you can change the shape of the offset substructure by regions. The default Small Region option allows you to move smaller parts, whereas Huge Region allows you to move major areas. Add and remove material in the Freeforming tab, or add attachments. To subtract the attachment, select Subtract. This enables you to remove or cut out specified geometries from the restoration part. You have the possibility to create attachments with a parametric design feature. Select the desired cross-section from the drop-down box in the Profiles window. The chosen profile will be extruded along the view axis. To place, hold the left mouse button to drag. Note, until you click Apply, you are still able to change the attachment design, even if it has already been placed. When you are done, proceed to the next step. Let's look at the extension and the space with a nice finishing line for the acrylic in the cut view. Let's compare the offset coping to offset substructure. In comparison, the offset coping on substructure creates an offset structure on a primary bar, whereas the offset substructure provides an option to define a second blockout area for gingiva bottom offset. This can be used, for example, to block out gingiva parts in case you design a monolithic denture structure on the bar by using an anatomic crown on substructure. In Model Creator, we have introduced new parameters, such as horizontal offset and vertical offset. These two settings control the spacing between an analog and the model base in horizontal and vertical directions, and they help you to compensate the fitting of the analog. It is also possible to have negative values to create more friction. Furthermore, in model attachments, you will find new options, such as 4-pin articulator full arch or quadrant. Place the attachment by left-click. You can move it by mouse left button. Note, to rotate an attachment, hold down Ctrl. And to remove, click mouse right and left buttons simultaneously. Another new option provided by Die Modelmacher has been added to our extensive library for full arch or half arch. In Plovdiv, after the smile planning on non-pre-prep teeth with Pontics, as the work type is done, you have the option to continue to the model design to create a mock-up model. Choose Plateless Model and follow the steps to create the model. For more information on how to create a model, please refer to our Model Creator video tutorial. Once the model is finished, switch to the Expert mode and with right mouse click, select Create Digital Waxup Model from the drop-down list. The software will save the digital waxup model in the project folder with the same name. Note, this digital waxup model is a watertight model with a combination of several shells penetrating each other, and the output is suitable for 3D printing. Thank you for watching this video.